I wonder why Mr. Black keeps showing us these strobe light photos of falling objects and images. I wonder if he's trying to lead up to something about falling objects and accelerated motion. Who knows? At any rate, today we're looking at a new kinematics equation. But first, let's make sure you really know how to apply equation 1. Read and think about the following. Go ahead, hit pause. I hit pause right about now. Remember our algebra. Equations can be rearranged as long as they have the right terms that we're looking for. What about this one? And again, you may want to hit pause. It comes pretty fast. Okay, so it's pretty clear we need another kinematics equation, and we got just the thing for you.
Now we're ready to go to the second motion equation. Whenever we are working with our displacement and velocity and time, we want to think in terms of our average velocity as being equal to the displacement delta d over the time interval. Okay? Now we've already showed how we can make delta d just plain d if we think about the displacement as being the final position minus the initial position of 0. And we've already simplified our time as the final time on the stopwatch. Okay? Average velocity now is not going to be the same at every point. Think about the graph that we have. If we have a velocity versus time graph, then what we're going to have is a linear relationship that will show us a constant acceleration. But our velocity vectors will be read across on the y-axis. So if this is our initial velocity and this is our final velocity, our average velocity is going to be the midpoint of this line. It's going to be the true average of the initial and final velocities. And so we have v final plus v initial divided by 2 because we're adding them up and divide by 2. It's the midpoint of those two endpoints, right? So if we add them up and divide by 2, we're going to find the midpoint. This is going to be the average velocity. Now what we can do is replace that, if you will. We're going to talk about the average velocity as v final plus v initial divided by 2. And we are going to make that equal to our displacement divided by the time. And so we can multiply both sides by t. Multiplying by t is going to get displacement alone. And we are going to have t on the top times v final plus v initial all divided by 2. So our displacement is going to be 1/2, since that 2 is in the denominator, v final plus v initial, there's our average velocity, half of v final plus v initial times the time, and that will be equal to the displacement. And here we have the second motion equation for constant acceleration.
So let's apply this and let's do some physics.
I am doing physics!
Yeah. So if this vehicle, this is the vehicle from last night's video, has an initial velocity of 14.5 meters per second, but after only 3 seconds of constant acceleration gets up to 46.0 meters per second, what distance will it cover during these 3 seconds. That's the type of question we can use this equation for. Well, let's do this with a little lip dub. I'm going to go ahead, and of course, we got D equals 1 half VF plus VIT. That's our second motion equation. So I go ahead and plug in some of them variables we have. 1 half because we want the average of the final velocity. It got up to 46.0 meters per second. But of course, it began at only 14.5 meters per second. And it's been running for 3 seconds. So we go ahead first and do that math. Half of what? That's going to be our average. We'll first add up to 2. And that's 60.5 meters per second times the 3 seconds. That would make our actual average velocity be half. But first, you'll notice that we're doing meters per second times second, meters per second times seconds. That means we got meters, and you should do that. Do your dimensional analysis. Just do it. It's 90.8, 90.8. Significant digits. All right, let's see if he does better on this. Remember the guy who discharged a gun in the air? Well, let's suppose after 4 seconds it's 260 meters per second. How far has that birdshot gone into the air from where it originally exited the barrel of the gun? So that's a good motion equation 2 question as well. Oh yeah. Look at him go. Alright, I see my VF and VI. Yep. Looking good. Nice, 280 meters per second average. Times your time, your average velocity times time. That's displacement. Nice. Oh, he just beat 1,100 meters, buddy. Don't choke on those significant digits. All right, and our last one. Punter accidentally puts his punch straight up in the air at a velocity of 29.4 meters per second. There's my initial. 6 seconds later, it's minus 29.4. What was the displacement?
And the displacement's going to be the average, but it end up minus 29.4 meters per second. It started at 29.4 meters per second over 6 seconds. But the point is, you're just trying to find an average of 0. Well, that's 0, and there was no displacement. I mean, in the end, yeah, it moved, but there's no velocity because the displacement, its final position is the initial. You see what I'm saying? So you see where this is going. So it's 0 meters, and that's a very embarrassing position. What's the point?
Ouch!